All right. So this is one of my theories that gets deeply conceptual, and I think is worth some thought because I was thinking about, in one of my videos, I was talking about like orbitals and, how basically particles or like electrons will like orbit around, and I drew these circles of with the graph, the lines of, or the axes of uh real and imaginary axes with the circle, and I was talking about pi and how you need pi energy or like interactions to revert the energy back. And I was talking about all of that, and that's because that's a 180 in direction, that's a 180 in momentum. So you got to apply that much energy back in order to reverse the direction and the energy and the momentum and all that, right? So I was talking about all of that, and then I started getting to thinking, if that is how it works when a block hits a wall, right? If we imagine a block hits a wall and pi is sent back, right? And, if that's what's happening there, right? What if it's like that because at the fundamental level, at the particle level, basically, the initial particles are, because what you really need to think about here is that all of this matter around me, right? All the matter that's here is effectively empty space, right? Because if we zoom in, the size of an atom overall is, yay big, but the nucleus is just this tiny little speck in the middle, right? So there's a lot of empty space there. So effectively, there's a lot of nothing, right? And so if there's all of this, free space, all this emptiness, all this nothing, then there's plenty of room for particles, instead of colliding, instead of having direct collisions, what instead happens is you get these sort of flybys, right? Because when we look out into space, it's very like for larger planetary bodies, right, or celestial bodies, it's unlikely for them to just directly collide. They tend to kind of orbit around each other a little bit before they finally do, the collisioning, right? Before they slowly spiral into each other and go boop, right? So, what if every interaction at the fundamental level there's not actually a direct collision, and instead it's sort of this, kind of flyby, if there's enough energy there to bounce off, right? Then enough energy goes in that basically the front line of particles flies in and goes boom, flies by, has enough energy, left over that it comes back, and then boom, and now it sends the momentum going this way, right? And so there's some kind of interaction that happens there where we get this sort of flyby happening, and then they go back, and when the particles come back, it causes this sort of wave that goes boop, 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 right? Like now it flies towards this one, right? And then it goes and it pushes, and it like they fly around each other. And while they fly around each other, the momentum maybe pushes them back this way a little bit. and then, that affects this one, so then this one starts to move, and you get this wave that kind of perpetuates through the, overall material, and then you end up with the motion, moving with this also, like wave that goes through. And, the thing is, when you look at materials and you look at what happens when you hit them, we get vibrations, we get sound waves, right? We get this sort of wave-like behavior that perpetuates through the material, as it kind of moves in that direction, right? We see that, right? And so I was kind of thinking about, what causes that, and that seems to kind of fit into my notion here. And so what I'm trying to get at is, I was thinking to myself, well, what's the difference? What is the physical difference between, a direct collision and, say, two celestial bodies orbiting each other, what's the difference between a comet flying, or like an asteroid flying into a planet and crashing, or I'm not crash. See, it's hard to use like a celestial explanation for this, because it tends not to happen, right? Wonder why. So, you throw a ball at the wall and it bounces back off the wall, right? So that's a direct collision. And then you have interaction where maybe a comet or an asteroid flies by a planet, but it doesn't like fall into the planet, but it kind of flies around, it gets affected by the gravity and gets curved, but then ends up getting shot back in the direction it came with escape velocity, right? What is the difference between those interactions, right? What is the difference between, it flying in and getting flung back out the other side, and it hitting it and bouncing off, right? What is the physical difference between those two systems? And in my questioning, I really didn't know how to ask this, or who to ask this to, and how to get a clear answer and say this. So I asked this to ChatGPT, and so I didn't ask that necessarily specifically, but I asked a bunch of questions like, well, what does this collisions equate? What is like a direct collisions energy equation look like, and what is like a gravitational systems equation look like? And I got responses, and then basically the difference that it told me was that in a gravitational system, no energy is lost because all the kinetic energy is converted to potential energy in an idealized system. Whereas in a collision, energy is lost to things like, deformation, heat, and sound, and all that, right? And so energy is lost and it is not recovered in the collision, right? But then I asked, okay, well, what if, it's converted to potential energy, but that potential energy is in reference to the object that it achieved escape velocity from, right? So it's never going to recover that energy because it's never going to fall back down again, right? So isn't that energy effectively lost? And then ChatGPT was like, yes. And I don't a part of me is like, okay, you're using ChatGPT, like that could be wrong. But in my defense, any physicist you ask can also be wrong. So I don't know if there's that much of a difference there, right? And so the logic seemed to track to me. And so maybe that's completely wrong. And if it is, then, my bad. But I don't think it is. I think that from a logical standpoint, energy is lost in both equations. And if energy is lost in both equations, especially in an unidealized system where there's other things going on, right? because I asked for clarification, and I got clarification that there are, like, in the real world, there are other things at play that energy is lost to in, in an orbital trajectory, and when you're doing things like planning out, like, the paths for satellites and, like, trips out to other planets and things like that, it needs to be factored in. Like, those factors need to be factored in. What they are specifically, I don't remember. I'd have to go look again. But basically, energy is lost to external things, and I saw that as, well, that's heat and sound, and things being lost to deformation is effectively energy being lost to potential energy. That potential energy is worthless. It can't be used anymore, right? And so, effectively, I got two different systems that could be seen as physically the same thing. They both have energy loss in them. And so I am left with the question of, why can't direct collisions actually be, these orbital interactions instead? And maybe I'm missing something big here, but it would make a lot of sense why we end up with this. In order to reverse motion, you need to apply this pi amount of, pi amount of interactions, because that's a 180, and that is what's happening in the imparting of energy is a 180, because a physical, legitimate 180 is happening on the particle level. And I mean, I don't I don't know if I can prove this. I don't know if it can be disproved, because we would need to be able to basically we would need to use a electron microscope to watch, like, a collision, like, watch two particles hit and see what happens. And I don't know if we can do that yet. And I don't know if that would even be enough, because maybe it's not atoms that are doing this spinning around, and it probably isn't the atoms necessarily that are doing this spinning around, but it could be, like, the electrons in the atom, or it could be something else. Like, I don't know, right? I don't know. But I'm just kind of thinking here, and the fact that they could be seen as relatively physically equivalent leads me to wonder, right? And, again, getting back to a point that I really didn't think about, is that you don't see, planets bump into each other and, or like asteroids hit a planet and bounce off, right? They hit, and, and then that's that, right? Planets, you could see them collide, but I'm pretty sure if planets collide, they don't really bounce off each other and go their separate ways. They kind of mesh into one. In most cases, I think. I don't really know. But it's definitely not a bouncing off each other sort of thing. At the very least, it's kind of a mutual destruction, and then whatever's left over splits apart. Or at least I imagine. I don't really know, right? I don't know. But yeah, I wanted to say that with this also kind of came from using SEMs or TEMs to look at materials, right? It's shooting electrons, right? To see, like, And you can use this to see the different densities of materials. And I was thinking that, like, what if, you're shooting these electrons at this beam, right? And depending on how you're using it, denser materials are either darker or lighter. I believe was my, understanding from my little bit of research on this. And maybe it's because, you're shooting these electrons, and instead of them bouncing off, what's happening is that they're flying in and getting flung back rather than like this direct bouncing off, thing. Because, again, it doesn't really make sense for an electron to bounce off of a nucleus, so to say. If it actually was colliding with the nucleus, I think we would see a different interaction. And I also don't think that it really makes sense because electrons don't collide with the nucleus on their own. So I don't know if that really makes sense. But maybe I'm, again, missing information. But basically my theory is that, denser materials are either darker or lighter because either A, the electrons aren't making it through because they're getting flung back, or, they're able to pass through because the gravity's not strong enough to fling them back, right? So if the material isn't that dense, it can fly through without being impacted by the gravity of an atom in there, right? Or it's more likely to. But as it gets denser and denser, the electrons are more and more likely to, instead of bounce off, be affected by the gravity of that nucleus and be flung back, is what I was trying to get at. Because to me, that makes a lot more sense. I think it would be very unlikely for electrons to be shot at a dense material and bounce straight back, as if they were hitting a wall, because we know that there's mostly empty space there, is what I'm trying to get at. There's mostly empty space there. There's no wall to an electron. To an electron, there's a lot of nothing there. So the likelihood of them all bouncing directly off of atoms back is very unlikely to me, regardless of how dense the material is, because even the densest material is still mostly empty space. And so I think it makes a lot more sense that it's more of a gravitational impact that is what is sending the electrons back, especially since electrons orbit the nucleus. They do not fall into the nucleus. And when we see molecules form, we don't see electrons crash into or collide with the nucleus. No, we say they, join the other nucleus, or they get bonded with the other nucleus. They don't collide with the other nucleus, right? Even if they're in a different atom. So to me, it just doesn't seem logical to assume that they're bouncing back and that it's really more of this collision thing. And that was the precipice of this, because if they're doing it, if collisions happen like that for electrons, maybe it's not just electrons that this happens for. But maybe it is just electrons, and maybe electrons are really the driving force of collisions. But I don't think that makes sense, because we have, electricity, and electricity is the flow of electrons, and that would kind of throw everything off. So again, maybe not the case, but electricity being a thing is a whole nother argument for electrons not colliding with atoms, because imagine how many electrons would collide with atoms if they were flowing down a wire, right? But they just keep flowing. So I don't think that logic makes sense, to assume that they're bouncing back off. And I don't know if that's what the assumption is, but I'm pretty sure it is, and I don't think that makes sense. And so I think that this whole 180, everything's an orbital interaction, makes a lot more sense. And yeah, I think I rambled a bit there, but long story short, that's the cut and dry of it. So yeah, peace out.